In today's lesson, you will master the substitution method for solving simultaneous equations involving one linear and one quadratic equation. This is a fundamental skill for Cambridge 9709 Pure Mathematics 1, as it is the primary tool used to find the points of intersection between lines and curves, such as circles or parabolas. You will frequently encounter this in coordinate geometry and calculus questions. By the end of this session, you will be able to efficiently solve these systems and interpret the nature of their solutions using the discriminant. To solve a system where one equation is linear and the other is quadratic, we use the substitution method. Our goal is to reduce a system of two variables into a single equation with one variable. First, rearrange the linear equation to express one variable in terms of the other. It is usually best to pick the variable that is easiest to isolate to avoid complex fractions. Second, substitute this expression into the quadratic equation. This creates a single quadratic equation in one variable. Third, solve for that variable. You can use factorization, completing the square, or the quadratic formula depending on the numbers. Finally, substitute your found values back into the linear equation to find the corresponding values for the second variable. Always use the linear equation here, as it is more direct and avoids extra phantom solutions. Let us apply this methodology to find the intersection of a line and a circle. Consider the equations. X plus y plus 1 equals 0, and x squared plus y squared equals 25. Step 1. Rearrange the linear equation. First, we isolate y in the linear equation. This gives us y equals negative x minus 1. Step 2. Substitute into the quadratic. Next, we replace y in the circle equation. Notice how we use brackets to ensure the squaring is applied to the entire expression. Expanding the bracket, remember that negative x minus 1 all squared is the same as x plus 1 all squared. This leads to x squared plus 2 times plus 1 equals 25. Moving everything to one side gives us our quadratic in standard form. 2x squared plus 2x minus 24 equals 0. Step 3. Solve for x. We can simplify this by dividing the entire equation by 2, resulting in x squared plus x minus 12 equals 0. This factors easily into x plus 4 and x minus 3. We find that x can be negative 4 or positive 3. Step 4. Find y values. If x equals negative 4, y equals negative 4 minus 1, which is 3. If x equals 3, y equals negative 3 minus 1, which is negative 4. Substituting these back into our rearranged linear equation, we get our two coordinate pairs. The line intersects the circle at these two distinct points, negative 4, 3 and 3, negative 4. Today we look at the nature of solutions and the discriminant. When you substitute a linear equation into a quadratic, you always end up with a quadratic equation of the form ax squared plus bx plus c equals 0. The discriminant of this equation, b squared minus 4ac, tells us the geometric relationship between the line and the curve without needing to solve for the coordinates. If the discriminant is positive, there are 2 points of intersection. The line is called a secant. If the discriminant is exactly 0, the line touches the curve at exactly 1 point. In this case, the line is a tangent to the curve. This is a very common exam requirement. If the discriminant is negative, the line and the curve never meet. There are no points of intersection. Notice the visual difference between a secant, a tangent, and a line that misses the curve entirely. Understanding this link between algebra and geometry is key for high marks in Pure Mathematics 1. Let's solve a typical Cambridge-style question. Find the coordinates of the points of intersection of the line 2x plus 3y equals 7 and the curve 3x squared equals 4 plus 4xy. Step 1 is to isolate y. We rearrange the linear equation. It is easier to isolate y here to avoid dealing with x squared and xy simultaneously later. Step 2. Substitute this expression for y into the curve equation. To clear the fraction, we multiply the entire equation by 3. This makes the algebra much cleaner and reduces the chance of arithmetic errors, expanding the brackets on the right side. rearranging into standard quadratic form. Step 3. Solve for x. Using the quadratic formula, the discriminant inside the root simplifies to 1600. This gives us x equals 28 plus or minus 40, all over 34. This gives us two values, x equals 2 and x equals negative 6 over 17. Finally, step 4. Find the corresponding y values. If x is 2, then y equals 7 minus 4 over 3, which is 1. If x is negative 6 over 17, then y is 131 over 51. The intersection points are 2, 1 and negative 6 over 17, 131 over 51. Let's look at where students often lose marks in these questions. The most frequent error is failing to expand binomials correctly. When you square a bracket like negative x minus 1, remember that you must generate that middle term. Always write it out as 2 brackets if you are unsure. Students often stop after finding the values for x. In a simultaneous equations question, a solution consists of pairs of x and y. If you don't find the corresponding y values, you will lose at least 2 accuracy marks. While substituting back into the quadratic equation works, it often produces extra values that don't satisfy the linear equation. To stay efficient and accurate, always use your rearranged linear equation to find the second variable. When a question mentions that a line is a tangent to a curve, many students try to solve the equations directly. Instead, you should set the discriminant of the combined equation to 0. This is a specific exam trigger word you must recognize. In Cambridge 979 examinations, marks are heavily weighted toward the method. Even if you make a calculation error, you can still earn method marks for correctly substituting the linear expression into the quadratic. Always show your substitution step clearly. If you jump straight to a simplified quadratic and it is wrong, you lose all subsequent marks. By showing the substitution, you secure the first mark regardless of your algebra. Accuracy marks are usually awarded for the final pairs. Ensure you link your x and y values clearly. For example, write your final answers as coordinates, or as clear pairs such as x equals 2, y equals 1. Another tip: if a question asks for exact values, do not use your calculator to give decimals. Leave your answers in fraction or surd form. If the quadratic doesn't factorize easily, the quadratic formula is your safest bet to maintain that exactness. Finally, keep an eye on the number of marks. A 5 or 6 mark question expects a full derivation of the quadratic in the solving process. A 2 mark question might just be asking for the number of intersections, where you only need the discriminant. Today we will master solving simultaneous equations where one is linear and the other is quadratic. This is a fundamental skill in the Pure Mathematics 1 syllabus, frequently appearing in coordinate geometry and calculus questions to find points of intersection. The primary method used is the substitution method. First, rearrange the linear equation to isolate one variable. Then substitute this into the quadratic equation to obtain a single quadratic in one variable. Finally, solve for that variable and substitute back to find the second variable. Let's look at example 1. The intersection of a line and a circle. We have the linear equation x plus y plus 1 equals 0 and the quadratic x squared plus y squared equals 25. Step 1. Rearrange the linear equation to get y equals negative x minus 1. Step 2. Substitute this into the circle equation. This gives us x squared plus the square of negative x minus 1 equals 25. Expanding and simplifying leads to the quadratic equation 2x squared plus 2x minus 24 equals 0. Dividing by 2, we get x squared plus x minus 12 equals 0. Factorizing gives x plus 4 times x minus 3 equals 0. So our x coordinates are negative 4 and 3. By substituting these back into our linear equation, we find the y coordinates are 3 and negative 4 respectively. Geometrically, this represents a line intersecting a circle at two distinct points. Negative 4, 3 and 3. Negative 4. The number of solutions is determined by the discriminant, delta, of the resulting quadratic equation. If delta is greater than 0, There are two intersections, and the line is a secant. If delta equals 0, the line is a tangent touching at one point. If delta is less than 0, there are no real roots and no intersection. Let's tackle an exam-style question. Find the coordinates where the line y plus 2x equals 5 meets the curve x squared plus y squared equals 10. Isolate y to get 5 minus 2x. Substitute this into the quadratic. Squaring 5 minus 2x gives 25 minus 20x, plus 4x squared. Combining terms, we get 5x squared minus 20x, plus 15 equals 0. Factorizing x squared minus 4x plus 3, we find x equals 1 or x equals 3. Substituting back into y equals 5 minus 2x, we get the points 1, 3, and 3, -1. Watch out for these common mistakes in exams. First, arithmetic errors when expanding brackets, especially with negative signs. Second, forgetting to find the y values after finding x. And third, incorrectly rearranging the linear equation. Always double-check your substitution. It is time to test your understanding. Please pause the video and attempt these 3 questions. Let's go through the solutions. For the easy question, equating the expressions gives x squared minus 2x minus 3 equals 0, leading to the points 3, 7, and -1, -1. The medium solution was already covered in our exam question. The points are 1, 3, and 3. -1. For the hard question, substitute kx minus 1 into the quadratic to get x squared minus kx plus 4 equals 0. Since it is a tangent, the discriminant must be 0. This gives k squared minus 16 equals 0, so k is plus or minus 4. To summarize, use substitution to reduce the system to a single variable quadratic. Always solve for both coordinates. And remember, the discriminant tells you if the line is a secant, a tangent, or doesn't intersect at all. For the first question, substitute y equals 2 times plus 1 into the quadratic. Setting them equal gives 2 times plus 1 equals x squared minus 2. Rearranging, we get x squared minus 2 times minus 3 equals 0. Factorizing gives the quantity x minus 3 times the quantity x plus 1 equals 0. So, x is 3 or -1. Substituting back into the linear equation. If x is 3, y is 7. If x is -1, y is -1. The solutions are 3, 7 and -1, -1. First, isolate y. Y equals 5 minus 2 times. Substitute this into the circle equation. Expanding the brackets, x squared plus 25 minus 20 times plus 4 times squared equals 10. Simplifying, we get 5 times squared minus 20 times plus 15 equals 0. Divide by 5 to make it easier. X squared minus 4 times plus 3 equals 0. Factorizing gives x minus 1 times x minus 3 equals 0. So, x is 1 or 3. If x is 1, y is 3. If x is 3, y is -1. The coordinates are 1, 3 and 3, -1. For the hard solution, substitute y equals kx minus 1 into the curve. This gives kx minus 1 equals x squared plus 3. Rearranging into standard form, x squared minus kx plus 4 equals 0. Since the line is a tangent, the discriminant must be 0. Substituting our coefficients, -k squared minus 4 times 1 times 4 equals 0. This simplifies to k squared minus 16 equals 0. So k squared equals 16, which means k equals 4 or -4. To conclude, let's summarize the essential points from today's lesson on simultaneous equations. Substitution is the primary method for linear quadratic systems. Always rearrange the linear equation first to isolate the simplest variable. This reduces the system to a single quadratic equation. The discriminant reveals the geometry. Remember that b squared minus 4ac determines the number of intersections. A positive value means two intersections, 0 means the line is a tangent, and a negative value means no intersection. Completing the solution. An exam solution is only complete when you have found both the x and y values. Always substitute your results back into the linear equation to avoid errors. Precision and algebra. Be extremely careful with expanding brackets, particularly when squaring negative terms. Show every step of your substitution to secure method marks in your Cambridge examinations.